Okay guys, here's the first video to help you getting started doing your own proofs here for geometry class. On the front of our Moodle page I've got this quote, "Training the mind in clear and rigorous thinking." And a lot of times you're asking me, what am I ever going to use geometry for, or really any of your classes you study here in school, what am I going to use that for in my future? This thing we're going to do with proofs in geometry is probably gets right to the heart of why we even bother going to school and why your parents are paying this money. We're trying to train you to logically analyze ideas and present clear and concise arguments. And this is probably one of the few classes you'll have anywhere that help you specifically do that. So how are we going to get started and how are we going to get good at this? The first thing you have to do is you have to really know the definitions, postulates, and theorems that we've talked about in class. You're going to have to look at and analyze a lot of examples of proofs, and I'll show you how to properly do that. Then when you get ready to do your own proofs, you're going to have to develop and have a plan. And then of course the toughest part is you're going to have to struggle and do a lot of practice. We'll cover the first couple here in the video, and then the next planning and practice we'll cover in a subsequent video. So how are you going to get familiar with all the postulates, theorems, and definitions here in class? If you look in the back of your book, I've showed you guys where they have the section listed postulates, and then there's a section listed theorems, and of course definitions. And every postulate we're going to use in class is listed here on the page. So I just went through and I highlighted. They're listed sequentially, so from the first day of class all the way through to what we've covered so far at the end of chapter 2, which is the linear pair postulate. And they also list a page in the book that you can go back and see where that postulate was introduced, and probably where there's some examples. So the linear pair postulate was introduced on page 111. Theorems are listed the same way, starting at the beginning of the book. For instance, this is theorem 2.1. The number doesn't mean anything. That just means it's the first theorem of chapter 2. And then of course the theorems are listed. So we've only been through two chapters so far. We've only covered through the vertical angles theorem on page 112. And again, the page numbers are listed. The glossary in the back of the book has all the definitions we're going to use for our proofs. Unfortunately, it also has a lot of other words, and it's not quite organized sequentially. Of course, a glossary is organized alphabetically, so we start with acute angle here. If you notice closely, though, they do give you the page number. This is introduced on page 28. So as of chapter 2, we're up through page 125. So you could go through here real quick and highlight every word that we've talked about so far and make sure you're familiar with it and find out which ones we might use for proof. So I've got acute angle, I've got angle bisector, and basically I just flip through here and find every page where something is introduced. So down here I've got complements and complementary angles. Those are on page 46, so again I might want to review those. As I get those definitions down, what I'd like you to do is build a cheat sheet. Now this one's a computer one that I've posted online for you, but it lists basically the definitions of the, 50 definitions that we've covered so far. This lists the ones that are appropriate or that we're actually going to use in proof. And of course I'd like you to make this by hand, and instead of listing congruent segments, I'd like you to list the abbreviation that we'll use when we're doing proof. So for instance, if I was writing this out, my definition might have definition of congruent segments, definition of congruent angles. And these are just my list of reasons that I'm going to use when I'm doing a proof, and that way they'll be there and handy. When you get ready to do your definitions, I would go through and I call this building your own textbook. So take the definitions and start a definitions section in your notebook. 3-hole punch it and put this in here, and every time we cover a new definition, go ahead and add it to your list. So for instance, I've listed here congruent segments. So the definition of congruent segment, here's the abbreviation we'll use when we do proofs: def, the congruent symbol, and seg. So definition of congruent segments can be written shorthand. And then I've rewritten the definition as a conditional statement. If two segments have the same length, then they are congruent. Notice, since every definition is a biconditional, I've also written the other part here. If two segments are congruent, then they have the same length. This really only works for definitions, but it's written as the conditional and the biconditional. I've also got here the definition for complementary angles. And basically what I'd have you do is just go through and list, I think there's about 12 or 13 that we've done so far. I would list every one of those. Of course, I'd have a page also for postulates and a page for theorems. So here's one of the entries from my theorem section, and it says the congruent complements theorem. There's my abbreviation, congruent symbol, comp, theorem. And it says if two angles are congruent to the same angle or to congruent angles, then they are congruent. So again, it's written as a conditional statement, and we've got our hypothesis up here at the top and our conclusion at the bottom. So what you're going to do with all this is when you start to analyze a proof. So here's a proof that I've done, one of our examples from the worksheets that I gave you. And this is trying to help us show, it gives us that angle 3 and angle 2 are complements. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. I've got a diagram over here. It shows that this angle plus this angle is 90, and it shows that angle 3 and angle 2 are complements. Okay, and what they want us to prove is that angle 1 and angle 3 are congruent. Okay, right here's the proof, angle 3 and angle 1 are congruent. So as you analyze my proof, realize that every line in the proof is either a given, so it's either something that was written here in the given or that is explicitly shown in the diagram, or it's basically a conditional statement. So as you read through this, maybe you don't understand. You see that I wrote down given. That's how 80% of our proofs start, was just by listing the given, and I used the abbreviation G for given. And then I wrote this line, angle 1 and angle 2 are complements. Okay, and my reason for that was the definition of complementary angles. Okay, so maybe you don't understand how I made that leap. So what I would do is I would go to my definitions page and I would look up, okay, there's complementary angles, and I've got a couple definitions. It's an if and a then they're complements. So this one I did conclude they were complements, so I must have used the first part here of the conditional. And what you should do then, since this is my conclusion that you've seen me make, look up and see if you can find where the hypothesis is. Remember, it has to be listed somewhere in a previous step or explicitly shown on the diagram. So basically, I look up here above this line and I see two measures of angles that add up to be 90. Okay, so if the measure of angle 1 and the measure of angle 2 add up to 90, then I can conclude angle 1 and angle 2 are complements because of the definition of complementary angles. So for every step in a proof, it's possible for you to either find where it's given, either up here explicitly or written down in the diagram, and then find the conclusion. So where's the hypothesis? Where's the if part? And then, of course, this will be the then. My next conclusion says then angle 1 is congruent to angle 3 is congruent to angle 1. My reason is the congruent complements theorem. So maybe I don't see how I made that step, so I'll look up the congruent complements theorem. And I see that it says if two angles are congruent to the same angle, then they are congruent. So now I need to find that hypothesis. Okay, there's two angles are complement. There's two angles are complement. These two angles are both complement to angle 2. Therefore, then, angle 3 is congruent to angle 1. That's my conclusion, and there's my reason. So every step can be analyzed as a conditional, and that'll help you analyze the proofs that you're going to look at. Check out the next video, and I'll start going through some examples and show you how to plan a proof and how to work several of them.